Hello guys, this is Ms. Bushra from math class. Today I'll be talking to you about how to find a 0 point in polynomial function using a rational root zero theorem. So what is a rational root zero theorem? Now let b px is equal to axn plus bxn minus 1 plus cx minus 2 plus till the end the last term is going to be equal to d, which is a constant. So this is the general form of any polynomial function. Now, p, let's set that p are the factors of d, which is this term here. And q are the factors of a, which is this term here. So the theorem says that p over q, okay, the factors of d divided to the factors of q are possible zeros of px. How it is? Let's give an example. Now imagine that you have a polynomial function called px is equal to, let's change into this one, px is equal to 5x3 minus 2x2 minus 20x minus 8. So px is equal to 5x cubed minus 2x squared minus 20x minus 8. So what are p and what are q? So here you are. P are factors of, if you write the general form of the polynomial function, I'll be writing here quickly, very small, axn plus bxn minus 2 plus cxn minus 3 plus till the end d. So we said that p are factors of d. If you compare this polynomial function that you have to the general form, you would find out that a is equal to 5 and d is equal to negative 8. So a is the first term here and d is the last term here. So p are the factors of the last term of negative 8. All right, and let's go back. Q are the factors of a, which is number 5 here. I can see it is 5, so 5. Now what it does mean factors of a number? So if you have a number like 12 can be written like 1 times 12 or negative 1 times negative 12, as negative 2 times negative 6, as 2 times 6, and so on. So those are called factors for the number 12. So number 12 has factors as plus and minus 1, plus and minus 2, plus and minus 6, plus and minus 12, and let's not forget about 3 times 4 and negative 3 times negative 4. So you have here negative plus and minus 3 and plus and minus 4. So as you see, the pair that you can multiply to each other and you get the number, those are the factors. Now let's go back here to our polynomial function. So if I'll be looking about the pairs of here you are, if I'll be looking about the factors of p, it's going to be equal to negative 8 is equal to negative 4 times 2 plus 4 times negative 2, negative 8 times 1, or 8 times negative 1. So I'll be taking all of these, right, as factors. So from here, what do you see? Your factoring, you see you have positive negative 1, you have positive negative 2, you have positive negative 4, and you have positive negative 8. Now what about 5? You can see 5 can be equal to 1 times 5, negative 1 times negative 5. Yes, so let's take for q is equal to these factors, plus and minus 1, plus and minus 5. So let's apply the theorem directly. The theorem says that possible zeros of px are p over q. Alright, are p over q. So possible zeros are p over q. So you take all the factors that you have. P are the factors, as you say. P are the factors of d, the last term, and q are the factors of the first term here. Alright, so you'll be dividing p over q as you take plus here, you take plus and minus 1, you take plus and minus 2, you take plus and minus 4, and you take plus and minus 8, and you divide them, plus and minus 1 and plus and minus 5. You see, this is how many of them? 1, 2, 3, 4. You have 8 numbers, and you will divide them by 2 numbers and 2 other numbers. So you get you get a lot of numbers. So what you do is you divide as numerator, you take 1 by 1, and denominator also you divide 1 by 1. For instance, if you have plus and minus 1, you're going to divide plus and minus 1 over plus and minus 1. So you get plus and minus 1. Then you go to negative positive 2, we divide it by negative positive 1, so you get positive negative 2. For 4, you get the same. 8, you get the same. Now, let's go to the denominator, the other denominator, which is plus and negative 5. Positive negative 5. So you will get also positive and negative 1 over 5. You will get also positive negative 2 over 5. You will get also positive negative 4 over 5. And you will get positive negative 8 over 5. Now, according to the theorem, these are called, here you are, these are called here possible zeros of px. So I was saying that those were possible zeros of px. Now, which one or what are the ones from these possible zeros that are real zeros of px? So to figure out, you need to replace these values of x into p of x. So you go through all these values one by one, and you try to calculate for each of these values and try to find out which ones are going to cancel out our polynomial function. So let's try with 1, the first value, plus 1. So I'll be calculating p of 1. Here is going to be equal to x1 cubed plus 2x squared minus 20 times, hold on, times 1. Here is 1 minus 8. So what I get here is 5 plus 2 minus 20 minus 8. So obviously this is not equal to 0. So obviously it's equal to negative 21, which is not equal to 0. So that means that 1 is not a real 0 for px. Let's go to p negative 1. So you get here 5 negative 1 cubed plus 2 negative 1 squared minus 20 negative 1 minus 8. So I get here negative 5 plus 2 plus 20 minus 8. So what I get here is obviously 13, 11, 31. Then what I do next, I believe it's not 31, hold on. So 6 here, -6, -11, -11 plus 20, yes, so it is 9 plus 9, which is not equal to 0. Now, since it doesn't cancel out our polynomial function, so -1 is not a real 0. Let's go and figure out for 2. P of 2 is equal to 5. 2 cubed plus 2 times 2 square minus 20 times 2 and minus 8. Here is in 2. So let's calculate. So 2 cubed is equal to 8. 8 times 5 is 40. So I get 40 here. Then here 4 square is 4. 4 times 2 is 8 plus 8. Here -20 times 2 is -40. Then -8 here. So obviously 40 -8, 40 plus 8, -8 is equal to 0. So since it equal to 0, it cancels out our polynomial function. 2, alright, 2 is a real 0 of px. So I am wondering what about p of -2? Let's try to replace -2 or inject into our polynomial function. What do we get? So p of -2 is equal to 5 times -2 cube plus 2 -2 square, -20 times -2 minus 8. So what do I get here is -40. Here you get plus 8. Here you get plus 40. And here you get minus 8, which is equal to 0. So -2 is a real 0 also of px. So plus and minus 2 are real zeros, actually are real zeros here of px. So this is how you do exactly to find out about real zeros of px. If in a question ever that asks you to find out about the real zeros of px, so this is the theorem that you need to use to figure out about your polynomial function. The solution of your polynomial function, the 0 points or real zeros or roots, sometimes you may find this term. So that's it for today, and I'll see you next time.